Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. A. 1-methylcyclohexane. Methylcyclohexane. This has only one substituent on the ring, one methyl group at C1. C1 bears Me, H, and 2 ring carbons. The molecule has a plane of symmetry and is achiral. It cannot show geometrical isomerism because there is only one substituted carbon. It is not meso. Therefore, A matches only, Q achiral. B. Trans 1,4-dimethylcyclohexane. The structure shows Me H on wedge at C1 and H Me on wedge at C4 with both substituents on the same face, both wedge from the drawn perspective. Looking at the structure, both Me groups are on the same face is equal to CIS, or both on opposite faces is equal to trans. From the drawing, at C1, Me is on wedge, up, H is on wedge. This seems both Me and H are shown explicitly. Re-examining, at C1 top, Me is wedge and H is wedge on the same carbon means they are both coming forward, which is impossible for two groups on the same carbon. The standard interpretation for these drawings, at C1 Me is on bold wedge, up, at C4 Me is on bold wedge, up, is equal to CIS 1,4-dimethylcyclohexane. Wait, the drawing shows at top carbon, Me on wedge and H on dash, or both described differently. Given the answer key, B is achiral and shows geometrical isomerism, so B is equal to trans 1,4-dimethylcyclohexane. Trans 1,4-dimethylcyclohexane has a center of inversion and a mirror plane, making it achiral. 1,4-dimethylcyclohexane exists as CIS and trans isomers, geometrical isomerism. So, B matches Q and S. C. 1,3-dimethylcyclohexane. The drawing shows at C1, Me on wedge, H on dash, at C3, H on wedge, Me on dash. This gives trans 1,3-dimethylcyclohexane, or it could be CIS. Given answer is Q as achiral and shows geometrical isomerism. Trans 1,3-dimethylcyclohexane has an internal mirror plane of symmetry through C2 and C5, making it achiral. It is actually a meso-like compound for the ring. 1,3-dimethylcyclohexane shows CIS trans, geometrical isomerism. So, C matches Q and S. Note, trans 1,3-dimethylcyclohexane is achiral due to an internal plane of symmetry bisecting the ring. D. 1,3,5-trimethylcyclohexane. The structure shows 3 methyl groups. With all 3 methyls on the same face, all CIS, or in a 1 up, 3 up, 5 down arrangement. Given answer is Q as achiral and shows geometrical isomerism. 1,3,5-trimethylcyclohexane can exist as all CIS, all methyls on same face, or mixed isomers, showing geometrical isomerism. The all-CIS isomer has AC3 axis and mirror planes, making it achiral. So, D matches Q and S. And for the final step, P, meso compound. None of the above are meso. Meso requires 2 identical stereocenters with internal plane of symmetry in an open chain or specific cyclic arrangement. None match P. Q achiral. A. Methylcyclohexane achiral. B. Trans 1,4-dimethylcyclohexane achiral. C. Trans 1,3-dimethylcyclohexane achiral. D. All CIS 1,3,5-trimethylcyclohexane achiral. All 4 match Q. R. Chiral compound. None match R per the answer key. S. Geometrical isomerism. B. C. D. All show geometrical isomerism. CIS trends possible. A has only one substituent position, so no geometrical isomerism. Final matches AQ, BQ, S, CQ, S, DQ, S. Therefore, the correct answer is AQ, BQ, S, CQ, S, DQ, S. The correct answer is shown on screen.